We are focused on the origins of biodiversity. In other words, historically, what factors lead to the generation of the many, many different species that we have, and then how and why biodiversity is maintained. And this is, of course, a conservation interest. We want to know how to preserve biodiversity and to understand the factors that are contributing to the decline of species that we might care about. And we are standing in Ithaca, New York, about 2 miles from the Cornell campus. And this is a field, it's a swampy area where there's a lot of milkweed, and that happens to be the subject of much of my own research. Milkweeds in the Americas, mostly in North America, and then a few that make it into South America. And they are all characterized by being rather hostile environments for the insects that consume them. It's a hard life for some of the insects that eat milkweed. You can see here there's a monarch butterfly caterpillar starting its life on a swamp milkweed. And they face several barriers to feeding when they start feeding on a plant like this. And the picture starts very innocently, sometime in June, typically in central New York. Adult monarch butterfly that migrates up from Mexico will lay an egg on a plant like this. And from that innocent beginning, the egg hatches, and the first barrier to feeding that caterpillar faces are what we call trichomes. They're leaf hairs, and often, especially on the common milkweed, Asclepias syriaca, the monarch will shave a bed, removing all the trichomes on the leaf. And it's truly remarkable because that caterpillar is getting no nutrition from cutting those trichomes. It has not fed at all yet. It's just hatched from its egg. And before it can get any nutrients out of the leaf, it must kind of clear that slate. Once the caterpillar shaves the lawn, it sinks its mandibles into the leaf, and it's faced with a very toxic, gluey, gummy substance we call latex. Latex is an amazing plant defense because about 10% of plants have latex. Not just milkweeds, but 10% of all plants. If you break a dandelion stem, you'll notice the little white milky substance. If you've broken a leaf off of a fig tree or a euphorbia, many houseplants have latex. And latex is a tremendous barrier to feeding. It gums up the mouth parts. It would be like if you scaled things up, getting a gallon of paint thrown into your face as you're trying to eat dinner. And not only is it a gummy, gluey substance that gels, it coagulates upon exposure to the air, but also it is packed full of toxins. From an insect's perspective, all of the cells in the animal's body basically stop functioning normally when they are getting these cardiac glycosides, or the cardinalides. That's the scientific name for the compounds. And only insects that have a special adaptation, it's a single genetic change in the monarch butterfly, only insects that have that special adaptation are able to feed on these plants. So you'll find many of the insects in this field simply do not touch milkweed because of those potent toxins. Nonetheless, if you look at the leaves, you'll see that there's plenty of damage on the leaves, and that's because there's a community of insects that specializes and only feeds on these plants. One of the most remarkable things they do is they disarm the latex system of the plants. So the latex system is canals that flow throughout all the leaves, and they're under pressure so that when you break a leaf, it oozes latex. And of course, all children that live in an area where there are milkweeds have experienced the white gummy stuff that comes out. What the caterpillars do is a behavioral mechanism to disarm that pressurized latex system. They will sometimes spend an hour cutting a notch. Basically, they cut that latex, the latex delivering canal, with taking great pains. The leaf eventually kind of falls over or is bent down, and that indicates to us and to the caterpillar that the latex is no longer flowing because the pressure has been taken away. And then the caterpillar will feed on the other side of that cut. One of the most interesting things is sometimes it'll spend an hour cutting the trench and only 20 minutes very hungrily eating the leaves on the other side of that cut. And then again, there are physiological and molecular adaptations to deal with the poisons. Still, I think one of the remarkable facts of life is that if you think about each monarch butterfly female having 200 to 400 eggs, if the populations are going to stay constant over time, what that means is that 99% of those eggs that are laid, hatched, start growing, don't make it. They die. And so if you walk through a field like this and you find dead monarchs, as we often do, either insects have eaten them, birds have pecked at them, they've drowned in the latex, that's just the normalcy of life for these butterflies, because they produce many more eggs than could replace them. And so only if 1% of those eggs survive, then the populations will actually remain constant. Although we've chosen to work on milkweeds for various reasons. They're abundant in central New York. They're attacked by by a beautiful fauna of insects, not only the monarchs, but beetles and other flies and other pests. They are not unique. When you walk through a field or a forest, you may think that you're walking through sort of a static community, but in reality, that forest or field is providing all of the energy for all of the organisms that live on the planet. And because of that, because there has been tremendous selection on the plants, pressure on the plants because they're being consumed, all plants have a host of toxins and defenses that they utilize to reduce herbivory. Yes, occasionally you see a tent caterpillar or a gypsy moth outbreak in the forest and they defoliate all of the green. But by and large, the world that we live in is green, and that is because in large part plants are protecting themselves with toxins and thorns and other mechanisms. And so I like to think of the milkweeds as simply one microcosm or one example of the ways that all plants have to cope with being consumed and sort of facing life in a diverse world where there are caterpillars and deer and other animals that want to consume them. And I think to really wrap it up, we believe that it's that reciprocal interaction between plants and the things that eat them that has generated a fair bit of the biodiversity that we see on the planet.